Hello everyone, Arsham back here from San Elemento after quite a long time, and today we're going to talk about the nftables on Linux Red Hat Enterprise, a version 8. And we're gonna talk about some facts about the nftables and the differences between the iptables and how we can actually manage an nftable, how write some rules on it, and how we can actually filter and do some NAT source and destination NAT using the nftables. So here's our little scenario here. As you can see, we've got two Linux servers, which is the CentOS and one is the Ubuntu. So they are both connected to the EXXI server, which is our gateway 192.168.102, and this is connected to my access point and to wireless radio and so on. So I'm not going to write those IP addresses for you for sure, because that's a security violation. And so this Ubuntu is going to act as a router, and this CentOS is going to connect through this Ubuntu server and then connect to the outer internet. So let's see how we can actually configure this scenario. So this is my Ubuntu. As you can see, the IP address says on ENS34 192.168.100.152, which is this interface, E00, and then 192.168.56.131, which is the E01. So my CentOS and ENS 192 got the IP address of 56.133. So there is no internet connectivity for this CentOS, unfortunately. But fortunately, this Ubuntu got internet connectivity. So first of all, let's make sure that these CentOS can ping the Ubuntu server. So ping 192.168.56.131. There you go. It's actually pinging the Ubuntu server, so that's fine. And to make everything right, I'm gonna make sure that I route add default. I'm gonna add a default gateway for this bad boy. If I exist, yeah, because I've already added a default gateway. So destination all zeros, which means this is a default route. Gateway 192.168.56.134. So this line basically means that please, if any packets you didn't know where to send it, just send it to this gateway, which means a default route. The matrix 0 means it got the most priority, the toppest priority of all the other routes. So that's fine for the CentOS, and ping 192.168.102 for the Ubuntu, so you can actually ping our EXXI server. There you go, that's fine. So let's make sure that this Ubuntu server is actually acting like a router. So hold on. Sys, what was it? I really don't remember. And okay, that's cat proc sys net IPv4. That's IP forward. So that's a number 1, which means this Ubuntu is actually acting as a router. But remember something. If this number is 1, that's fine. But the problem is that when you reboot your server, this is not going to act as a router anymore, because this thing, this configuration, is only valid when your router is not rebooted. So you have to do something else. sysctl.conf, and on this line, net.ipv4.ip-forward equals 1. This is a persistent change. If your router gets rebooted, it still will be acting as a router. So that's very important to remember. Put this number as a 1. So I've already done it, and WQ to save stuff. There you go, it's acting as a router. So let's talk about the nftable and a brief review on the tables. So nftables got some tables, chains, and rules to write a rule on it. So first of all, we're going to talk about the nftables table. So nftable table is kind of a namespace which contains chains and rules and objects and etc. on it. So we're going to configure an nftable table and a name, for example, nftable, nft, okay, add table, NAT, for example. So I just configured a table, but remember something. If I say nft list rule set, you can see it's actually a little bit different with this one. It says table IP NAT, but I said nft add table NAT. It's not IP NAT. This IP is an address family. So address family is very important when you're defining your tables. So it's basically saying, hey, nftables, I'm using the IP, more specifically the IPv4. So if you're going to configure this to work as an IPv6, you have to say nft add table. IPNAT is IPv4, but IPv6 means work as an IPv6 table. So, which means, sorry, nft add table IPv6 NAT. So because I've configured NAT before, that's not going to work. We got other stuff as well. For example, nft add table inet. Inet means work for both IPv4 and IPv6. That's the inet address family. So for now, we're just going to configure nft add table NAT. All right, so we just configured our table, and let's configure our chain. So we have to configure our chain so we could configure our rules and put them in our chain. So a chain consists of many rules. So here's how we can actually add a chain on nftables. So we can say nft add two slashes. I'm going to tell you what those slashes are for. nft add chain IP NAT pre-routing. And if you don't know what that pre-routing is, I'm going to tell you in a minute. Just hold on. Hook is pre-routing, then priority, for example, -100. I'm going to make sure that this is my top priority. There's something wrong. Yeah, there you go. Pre-routing, no. And type NAT hook pre-routing. So if you configure this line as if it was this, so it's telling the nftables, hey, I've got a chain with the priority of 100. It doesn't realize that this is -100. So you have to add those two slashes to tell nftable, please consider this chain as a priority of -100. I know this looks a bit weird, but that's how does it operate. I'm really sorry. So we just configured a pre-routing chain. And the next one is a post-routing chain. I'm going to tell you what all those things are. Let's hold on a minute, please. Post-routing with a priority 100, for example. That's not really important because that one was... No, sorry, what happened? 100 and... There we go. So... what is this post-routing and pre-routing? Let me open a Paint and tell you something. Right, this is my Ubuntu server. Oh, that's too big. And a little bit smaller. All right, that's fine. This is a packet. Sorry, I'm using a mouse. I'm not going to write it very well. This is a packet coming from my Ubuntu server. So my Ubuntu server should know something. If this packet is going to this inputs interface, the chain input, which is mostly used for filter chains, it means, hey, do something to this packet before it is pre-routed or before it is forwarded in my Ubuntu server, which is our filter chain. Or when the packet is actually going out from my Ubuntu server, call it the output chain, please do something. For example, if you were about to send this packet through this interface, now you can send it through another interface on output chain. But for NAT chain, we've got pre-routing, okay, and post-routing. So it basically means, hey, Ubuntu, listen to me. If a packet's coming through your operating system, do something before it is routed through you, which is pre-routing, which we basically configure these kind of chains for NAT, and also post-routing for NAT as well. So we're gonna say, hey, if the packet was about to going out from your server, do some modification on this packet. So it's very important for you to know that. And I mean, if you know about this Cisco access list and ACP, you got to be familiar with this stuff. So here's my chains, but hold on, there is no rules for any of these chains. So NFT add rule, right, and IP NAT, or you could say just NAT, doesn't make any difference. Post routing, let's say, all right, NFT add rule NAT post routing, oath name, what was my interface name, ENS 34, which is 192.168.100.152. 34, use the masquerade. So I'm telling it, hey, if any packet come through you, I mean your outputs, your ingress interface, use the masquerading, use your interface IP, and do a NAT for these packets. So if I'm going to ping 48, there you go. We've got internet connectivity, and this CentOS is connected to the Ubuntu. So now I can actually connect through the internet. So remember something, you can actually see the TTL is 127, but here on Ubuntu, if I ping the internet, the TTL is 128. Why is that? Well, as a default, my TTL is 127, which is configured. But the CentOS TTL is 127, which means, hey, I'm connected to a server, which is actually a NAT server. So a NAT server here, which is Ubuntu, is going to decrease the TTL number by 1. So this is actually decreasing the TTL number by 1, so I can realize that it is connected to a router, and it's connected to the internet through that router. So everything's working fine because I know it's connected to a server, which is the Ubuntu server, and then it's connected to the internet. So that was everything about the NAT and masquerading. So please consider subscribing to my YouTube channel for more videos.